So when we talk about the discriminant, this is only the part that is under the root, which is b square minus 4ac. And we have three different cases for this. It could be greater than 0, equal to 0, or less than 0. Greater than 0 means positive value, equal to 0 is obviously 0, and less than 0 is negative value. What do we get from these three? Whenever it is greater than 0, it intersects at two different points. B square minus 4ac is greater than 0, and this could be in both the ways. Remember, we discussed about ax minus h whole square plus k. This a decides if it is a smiley face or a sad face. If it is positive, it is a smiley face. Negative, it is a sad face. And b square minus 4ac, being positive, being greater than 0, decides that it intersects at two different places. So when it is greater than 0, it intersects at two places. When it is equal to 0, it intersects at one place. And when it is less than 0, it never intersects. So that is no solution. So b square minus 4ac, b square minus 4ac, and the third one b square minus 4ac. When it is greater than 0, we have two solutions. When it is equal to 0, we have only one solution. That means it is a tangent, it just touches the line. And when it is b square minus 4ac less than 0, it never touches the line. No solution. And if we have a sad face, there are still two solutions in the first case, still one solution in the second case, and no solution in the third case. Now, for understanding, sake of understanding, how do we go about it to accept the fact? For example, we have minus b plus minus square root b square minus 4ac over 2a. And let me say the value of a is 0.5, just to make the discussion easy, that 0.5 into 2 would be 1. And let me say the value of b is negative 10. So if I plug in negative 10 here, plus minus whatever is under the root, b square minus 4ac, which we'll be discussing shortly, divided by 2 into 0.5. This makes it 10 plus minus square root something divided by 1. So I don't have to write that. Now we are discussing what happens when the value is positive or negative. So these are the three cases: b square minus 4ac, b square minus 4ac greater than 0, b square minus 4ac equals to 0, b square minus 4ac less than 0. Three cases. So just suppose we take this value greater than 0 as 16. Just an example. So we will have two different values. 10 plus 4 is 14 and 10 minus 4 is 6. So with an example, are we clear that this will intersect at two different places, which will be 14 and 6? And when the discriminant b square minus 4ac is equal to 0, square root 0 is 0. So when we add and subtract 0, we always get 10. 10 plus 0 is 10, 10 minus 0 is again 10. So it intersects at one place, that is 10. And in the third case, when the discriminant is less than 0, means it is a negative value. So 10 plus minus square root, whatever value you choose, if it is negative, that means no solution or no real root. No real root means it is not intersecting the line. So that's how you'll remember these three cases: greater than 0, equal to 0, or less than 0. Now what actually happens is that you will be having two equations. One is quadratic, the other is linear. And something in between them would be missing. Let me select one question from this sheet. For example, question number 3. It says find the set of values of m for which the line y is equals to this line right here, mx plus 4, y is equals to mx plus 4, intersects the curve y is equals to 3x square minus 4x plus 7. Okay, the statement is find the set of values of m for which the line intersects this curve at two distinct points. So the question is already made it clear that this is the first case and it intersects at two distinct points. So one thing we are sure about is we will be using b square minus 4ac greater than 0. Any doubts in this case? So the value of m is unknown. In order to find the intersection and the value of m, I'll have to substitute them. So I'm substituting equation 1 in equation 2 and writing mx plus 4 is equals to 3x square minus 4x plus 7. Now second step, I'll rearrange them and simplify. 3x square is already there, minus 4x is already there, bringing mx on the other side, minus mx, bringing 4 on the other side, 7 minus 4. So rearranged 3x square, I'm taking out x as common and left with minus 4 minus m plus 3. Now I know a, b and c. A is 3, b is minus 4 minus m and c is 3 again. So I have this a, b and c, and it is already clear that b square minus 4ac is greater than 0 because it intersects at two different places. So we'll plug in the values. Minus 4 minus m whole squared minus 4a is 3, c is 3 again. Simplifying this would give us the value of m. So a square minus 2ab plus b square and this is 4 into 3 into 3 is 36 greater than 0. Rearranging again, m square plus 8m minus 20 is greater than 0, and you can use quadratic formula or midterm breaking both. So m square plus 10m minus 2m minus 20 greater than 0. M plus 10 minus 2 m plus 10 greater than 0. So m minus 2 and m plus 10. So m is greater than 2 and m is greater than minus 10. This is not the final solution. Now we already know by looking at this equation or the simplified form, this second one, m square, that is the general form of ax square plus bx plus c. So coefficient of x square, in this case m, that is positive, it means it is a smiley face. First thing. Second thing, we have two solutions. One is minus 10, the other is positive 2. Last thing, this very equation is greater than 0. Greater than 0 means we are shading these two parts which are above the line greater than 0. So this shaded region is actually my answer. This shaded region tells me that this is m and this is m. So my final answer is m is less than negative 10 and m is greater than 2. This sign is actually reversed. So this is my final answer. One way of doing it is this. The other way is we solve this completely, reach this point, and then we draw a number line. We have these two values minus 10 and 2, and then we check for the regions A, B or C that which one is true. For example, we use this line and I am going to check for A. So can you hear me? So any value less than -10, suppose -12. So I'm plugging it in this -12 minus 2 into -12 plus 10 greater than 0. So this is -14 into -2, which is +28 is greater than 0. That is correct. So option A is correct. Then when we talk about section B, what do we get? Suppose we use 0 in this case. So 0 minus 2 into 0 plus 10 is greater than 0, and -2 into 10 greater than 0 is -20 greater than 0, which is clearly not true. So B is not my answer. Last section C, suppose we take 3 in this case. So 3 minus 2 into 3 plus 10 greater than 0, that is 1 into 13 greater than 0, and 13 is greater than 0, that is true again. So we have these two sections. So finally it is either less than 10 or more than 2. So m is less than -10 and m is greater than 2, and you can see these two are same. So whatever suits you, you can select those.